Hello everyone and welcome to Augmatic. So today I am excited to introduce our one of the product, that is the Lux sensor. So here I have the Lux sensor which has the specification of the closed loop analog output control. So here I have the baseboard. So in this baseboard here I have the reset button and here I have connected with the Lux sensor. So here I have the input part. So in this Lux sensor we have the two outputs, that is the analog output which provides the 0 to 10 volt and the RS485 output where user can calibrate the Lux sensor. So here I have the jumper part. This jumper part which is used for the setting the baud rate and the slave ID for the Lux sensor. So where user can set their own slave ID and the baud rate through the RS485, that is we are using the Modbus. So where user can set their own slave ID and the baud rates. So whenever we are changing the baud rates, the jumper should be in a single mode. So when we get the sensor to back the default IDs, so on that time we need to put a jumper as a close. So then press the reset, the board will get for the default. Okay, so this application, so where we this function is used in industrial lighting and the illuminating the control system. So where the LED and the light source operates together with the Lux sensor in the closed loop configuration. So where the system continuously compare the Lux value with the user defined calibration, where we user set their start and the end ranges, and then the driver which continuously compare the measure Lux. Okay, then it will automatically adjust the analog output to achieve the required light intensity. The ramped voltage that controls the prevent suddenly output changes, and which improves the stability in the hardware and reduce the electrical stress. So this approach is widely used in the smart lighting, machine vision illumination, and production lines, where and the greenhouses and the clean rooms and energy efficient industrial automation, where it requires the precious and the stable light control, which is critical. So on that time, this Lux sensor which helps the industrial area to prevent that stable intensity. So here I have connected with the Modbus. So for this setup, here I am using the LED dimming driver. So for this driver, I have connected in the input part as a, this is the Lux sensor. So the Lux sensor analog output I have connected to the driver input. So it will provide the 0 to 10 volt. So the driver output it will provide as a 24 volt. So I have connected with the LED which is runs at the 24 volt. So this analog output which drives the LED based on the Lux. So here I have connected with the Modbus. So in my Modbus, so board has properly connected. So currently I am getting the Lux as a 145. So for this, as by default you will get the Lux maximum range, and also in the end range you will get the maximum by default only. So at the first time user need to do the calibration for the Lux. So here I have provided the names for the registers, what are the registers I have used for the particular specifications. So here for the first register, at 0 register you are getting the current Lux values. So make it as a unsigned integer, so you will get the Lux full intensity value. So at the first register I am using the min range. So first we need to calibrate the Lux. So for that we without turning on the LED, so I am getting the Lux value as a 140 something. So that means that it is my minimum value, that is a 145 148 something it's showing. So this is my minimum Lux range. So I will set this minimum Lux range. So this is my 145 minimum Lux range. Okay, and at the max Lux range, so we need to calibrate. For that we need to get to know which is the max Lux range. So I will disconnect the device. So here the LED turn on. So currently I am getting the Lux value as a 10,800. So this is my the maximum Lux range. So I will get with the LED. So 10,800 is my maximum Lux range. So I will do the calibration as a maximum 10,800. So this is my maximum lux range. So here you can calibrate with the offset value as a positive and the negative. So in the 7th register and the 8th register, so I have provided the starting range and the ending range. So ending range is by default it will be a 65,000, where user can set their own ending range. So currently my lux maximum range it provides, that is the 10,800. So here I have the maximum lux range 10,800. So and in the end range, so I will give the I need a value which control the LED, drive the LED in the end range between the 9,000 and the 10,000. So in this range the LED should be a drive. So for that I will provide the end range as a 10,000. So and the starting range as a 9,000. Otherwise I will give as a 8,000. So the lux will drive until the LED, the current lux which matches with the range between the starting range and the ending range. So it's driving the LED. So here you will getting the lux rapidly increasing. So it will increase the millivolt every millisecond. See here the current lux range, that is a 8,400, which matches with the starting and ending range. So starting range, that is a 8,000. So currently the lux between the 8,000 and the 10,000, so it stopped the increasing the voltage, so it get the constant. So now if I can change the range between the starting and the end range, so according to that the lux will drive the LED. Whenever I change the starting and the ending range, the lux sensor which drive the LED based on the analog output. Here I have the analog output which is connected to the driver. So this lux give the output to drive the LED for the current lux range which matches with the starting and the ending range. So until it reaches the starting ending range, between that range, so it will stop driving the LED. So where this application are used in the industrial area. So whenever in the production line where the LEDs are used to illuminate the product for the camera inspection, where it needs the stable light. So over the time, sometimes the LED get lose the brightness. So instead of suddenly increasing the voltage, it get damaged for the remaining LEDs. So in that specific area, so this lux sensor which control the driver slowly by increasing the voltage until the required lux range which reach to the starting and the ending range. So the voltage will stop increasing automatically when the start and the end range which matches with the current lux range. So this helps the LED light as a stable. So here also you can change the baud and the slave IDs. So whenever we are changing the baud and the slave IDs, just we need to set the jumper as a single. So then we can change the baud and the slave IDs. So the board will configure with the new baud and the slave IDs. Okay, now I will set the baud rate as a 115200. Okay, here user can set the baud rate. So click on that and provide the baud rate as a 1152. For 00, just provide the 10. Okay, it will be multiplied by 10. That means 115200. Okay, now I will send the request. Okay, here the request has sent properly. Now I need to take the board for this current baud rate. Okay, for that just press the reset. Okay, for before pressing the reset, just once verify the jumper should be in a single, otherwise it should be a remove. Okay, press the reset. Here I will get the timeout error. Okay, when I will get the timeout error, go to the connection and disconnect the board and connect the board for the new baud rate. Okay, here the baud rate, that is I have provided 115200. Okay, click on that and okay. See, the board has connected properly for the new baud rate. Okay, now I want to set the slave ID as a 30. Okay, here we have the current slave ID, that is 1, and I need to set the slave ID. Here below we can set the slave ID. Double click on that, provide the required slave ID, that is 30. Otherwise you can set your own slave ID and send the request. The request has sent properly. Okay, now I need to get that board for the current slave ID. Just press the reset. Okay, here I will get the timeout error. Now go to the setter directly and click on read and write. Here provide the slave ID as 30, which is provided by user, and okay. See, the current board has connected with the new baud rate and the new slave ID. And according to this, you can set the slave IDs as another also. Now I will provide for the 19200. For that I will provide 1920. Send the request, and I will set the slave ID, that is 15. Okay, send the request. See, the user set 1920 and the slave ID as 15. Okay, now I will press the reset. See, here I get the timeout error. Okay, now disconnect the board and connect the board with the new addresses. Here I will go for the 19200, right? Click on that. Okay, then go to setup and change the slave ID, that is new, that is 15. Then enter. Okay, here the board that is communicating for the new slave ID and the baud rate. Okay, according to this only you can change your slave IDs and the baud rate. Here you can change the slave IDs up to 247. So this is all about the Lux sensor, which is controlling the LED through the driver, so which is used for the helpful in the industrial area.